associated. So let's get into the discussion of something called as expected value. And this expected value is also called as mean. Okay. So yeah, you have a lot of lines which are given here, and then you can look into that. This is also called as weighted average. So we'll talk more about that. Suppose you invest your money in a government bond, some government bond, which is also called as a T-bill or sovereign bond. Say you invested your money. And if the government says that on an average, you would get 8% return on investment, or you'll get an interest amount of 8% on an average. That means you would certainly get 8%. And what is the formula for mean? Summation of y equal to 1 until n xi divided by n. Okay, so if the value that you're going to get, if it is certain, then you can use the regular mean formula. If you invest in government bonds, certainly you will get whatever the government has promised you. If the government says that, you know what, invest in the government bonds and you will get on an average 8% interest amount, that means you will get 8%. That means this value is certain. There is no uncertainty here. If the value is certain, then you use the regular mean formula to arrive at this. If the underlying values are certain, then you use this formula. However, if the values vary or fluctuate, for example, if you invest in probably Google or Apple or any other stock, would you certainly get 10% return on investment? Would you certainly get 12% return on investment? Not really. When the markets are bad, you might get 1% return on investment. If the markets are good, you might get even 50%. Sometimes you might also lose the complete money that you have invested in the stock. It might happen. That might be a possibility. When the values are not certain, then you cannot use your regular mean formula. You cannot say that, okay, let me do one thing. Let me take the last 10 months data of Google on what was month on month return on investment, and let me take an average. You cannot say that because all these values are uncertain. There will be a lot of uncertainty in the data. The moment you have uncertainty in the data, probability kicks in. Right? The moment you have uncertainty, the concept of probability kicks in. Okay, and hence you take each value and multiply it with the probability value and then add them up. That would give you something called as expected value or mean. Expected value or mean. If you're wondering, and okay, if it's the same formula and if you're multiplying it with probability, where do I have n? Are you not dividing it by n? So for that, I would say that, you know what, probability formula is nothing but number of interested events divided by total number of events. Total number of events is n. So that n would anyways be there in the probability formula. So the only difference between your regular mean and the expected value is that you're multiplying each value with the probability, because the values, the underlying values are uncertain in nature. Now let's calculate this using a specific example of probability distribution. I need to show you probability distribution, and then we need to calculate quickly this expect. Okay, so this is what was the use case which we have already discussed about. And using this raw data, we have tried to come up with a probability distribution table. Whenever your underlying values have some probabilities associated, we cannot use the regular mean formula in order to calculate the overall average. On an average, how many iPads do you sell? You cannot just simply say that, let me take all these values and take an average, because all these values are uncertain. On certain days, you might sell 0 iPads. On certain other days, you might sell 4. So these underlying values are uncertain. Since the underlying values are uncertain, you need to use expected value formula. And this formula is summation of I equal to 1 until n xi into probability of xi. You have 5 values, so you write it as summation of I equal to 1 until 5 xi into probability of xi. When you substitute I equal to 1, you get x1 into probability of x1 summation, so you say plus. When you substitute I equal to 2, you get x2, multiply it with probability of x2 plus. When you substitute I equal to 3, it's x3 into probability of x3 plus. When you substitute I equal to 4, x4 into probability of x4, summation is plus. When you substitute 5, you get x5 into probability of x5. x1 is 0 into probability corresponding to that is 0.4 plus. x2 is 1 into probability corresponding is 0.25 plus. x3 is 2 into corresponding probability is 0.2 plus. x4 is 3 into the corresponding probability is 0.05 plus 4 into 0.1. When you solve it, you get, I think, 1.2. And that happens to be the expected value or mean pertaining to this data. This is an extremely important concept, and throughout our machine learning algorithms, we will be talking about this. A lot of algorithms depend on this underlying logic of expected value. It is that important. Okay, and we also have expected variance. Yeah. What is the formula for variance? Summation of I equal to 1 until n xi minus mu whole square divided by n. Okay, this is the regular variance formula. But the moment your underlying data has a lot of uncertainty, probability associated, then you calculate expected variance. This is how you do it. All you do is multiply it with probability. Take this and multiply it with probability. And if you're wondering on, hey, what happened to this n? You know for a fact that probability formula is number of interested events divided by total number of events. So the n would be there in that. So this is expected value for us. Next. Why did we talk about it here? Because we concluded both mean and variance. So we discussed this. The reason being, When we get into third moment and fourth moment business decisions, it comes in extremely handy. So now we are switching to something called as graphical representation, in which we are going to talk about bar plot, histogram. Then we will get into third moment business decision, fourth moment, because there is a dependency of histogram in understanding the third moment and fourth moment business decisions. And finally, we have box plot, not just box plot. We have a couple of other plots as well, which is QQ plot. Sorry, where did this pen go? We have something called as QQ plot, and we have something called as scatter plot. We are going to talk about all of these, and then we are also going to talk about correlation coefficient. And with that, we will take a stop, and then we will jump into, data cleansing stages. The logic and the flow would be very simple. We would understand the theory. We would go back and do it practically using Python. Okay, and a few of the thumb rules, which I would strongly recommend you all to do is A, maintain a running notes. Whatever is being discussed, whatever you're listening to, just keep making a running notes so that you're both physically and mentally present. Point B, read your mind map on a daily basis. Extremely important, friends. Mind map, you need to read it on a daily basis. Okay. So we have a bar plot. And you know what? We have this data. Let me open the spreadsheet of education dataset. And this education dataset has GMAT scores of 773 students. Okay, we have the GMAT scores of 773 students. Now, when you do a bar plot, each line or each bar that you see happens to be GMAT score of one student. Each bar represents GMAT score of one student. And you have 773 observations. That means you have 773 bars. Okay, you have 773 bars out here. What inference can we draw by looking at the bar plot? Nothing much. Probably you can say that, you know what, majority of the students have GMAT scores which are greater than 600. GMAT scores, the maximum GMAT score that one can get is 800. So, this is the max that you can probably comment, right? That, all these students have GMAT scores greater than 600. Apart from that, there is nothing much that you can glean from this bar plot. So when you have a lot of observations, bar plot is not a good visualization. Then what is a good visualization? A better visualization is histogram. And histogram is also called as a frequency distribution. This is also called as frequency distribution. So what is shown in this histogram is different bars. And on the x-axis, you will have random variable. In this case, this random variable happens to be the GMAT score. And on y-axis, you have frequency. Remember, any visualization that we look at, what are the things that we need to be aware of? Two. One is what would be on x-axis, another is what would be on y-axis. And here, we are doing a histogram only for a single variable called GMAT. So histogram is called as a univariate plot. It's called as a univariate graphical representation. Why is it called as univariate plot? Because you have a single variable. From 600 to 620, how many people do you have? From 620 to 640, how many people do you have? From 640 to 660, how many people do you have? 660 to 680, 680 to 700, then 700 to 720, 720 to 740, you have 150 students. 740 to 760, you have probably 60 odd students, so on and so forth. You have the bars. So histogram creates certain bins. Okay. And what it would do is, it would count how many students have the GMAT scores in between each of those bins or groups. So each of these are called as bins or groups. Okay. And within that, how many people do we have? Is what histogram will tell you. Try to draw parallels of histogram with the bar plot and try to understand. In a bar plot, each bar represented GMAT score of one student. However, when you look at histogram, it is a frequency plot. It's creating groups of bins, and how many people lie within each of the bin or group is something that you're trying to understand. And if you give this histogram to the dean of a college, what insights do they glean from this? Probably as a dean, someone would look at this and say that, okay, seems like a very less number of students are getting admitted into the college with the students with GMAT score less than 660, less number of students are getting admitted into the college. And who are these kind of people? Usually these are the people who are into probably non-math background, non-English background, maybe because GMAT will test you on English vocabulary, etc., grammar, and it will also test you on your analytical capabilities on math. So who are these people? Just to give you some sense, this guy called as Viren, if at all you guys remember him, he happened to be captain of Indian national hockey team, and he was member of 2004 Athens Olympics, and he quit international hockey in 2008. The reason being, he pursued his education in Indian School of Business. Indian School of Business, right? And that's the exact place where I got graduated, and I also trained the students of Indian School of Business. For those of you who are now not aware of, I'm one of the visiting faculties who train the students on machine learning. Okay, anyways, that aside. So these are the kind of people who might join your B school, and you cannot expect them to have extremely high, knowledge, or you cannot expect them to get very high GMAT score. But if they are included in your class, and if you sit alongside these kind of people, they give you different dimension, they give you different perspective altogether. When you as a group try to solve a business problem, how would a national team captain who represented India in Olympics, how would they think? What is their thought process? That is exactly what you learn. So as a dean of the college, certainly I might want to dig deeper to understand who are these people who are getting admitted into the college. Do they bring in different dimension to the curriculum, to the class strength, etc. Not just that, if you look at this, you know for a fact that majority of the students are getting a GMAT score in between 700 to 720. And very less number of students who have a GMAT score greater than 760 are joining this college. And these are the kind of people who might get salaries of $1 million. So you want to have them in your school, in your college, so that when they graduate and get hefty salaries, you want to probably use their information to do marketing. Okay. So probably as a dean of a college, I might want to give more scholarship to students who get GMAT scores more than 760 so as to attract better talent. So your histogram is giving you a lot of information. And this kind of information was missing from your bar plot. Okay. Now, there is something called as density plot or probability distribution plot. What was there on probability distribution plot? On x-axis, you had something called as random variable. And here we are using GMAT, which is a random variable. And on y-axis, we are having density or probability values. When you have density or probability values on y-axis, and when you have the random variable on x-axis, this would be called as density plot or probability distribution plot. While there is a thin line of difference between probability and density, you can for now safely assume that both of these are the same. Now, if you were to compare a histogram with a probability distribution plot, they both would be the same. The only difference is that in histogram, you have frequency on the y-axis. And when it comes to your probability distribution plot or a density plot, you would have probability values or density values on your y-axis. Barring this, both give you more or less the same information. Why did we talk about histogram? Because this information would get carried forward into the third moment business decision, which is called as skewness. We spoke about first moment business decision. And if I were to take the expected value of a mean, this is how it was. And then we have second moment business decision. And it is x minus mu whole square. We have looked at the expected value formula already. And we now have third moment business decision. It is anybody's guess to understand how the formula would look like. It would be x minus mu divided by sigma. And you would see a cube out there. So let me rather show you the formula. Okay. X minus mu by sigma whole cube. So in first moment, you have whole raised to the power 1. In second moment, you have whole raised to the power 2. But in the second moment, you are taking the first moment mu here. And this is your sigma or sigma squared, if you want to call it as variance. And then in third moment, you are having x minus mu by sigma. The sigma is going there and 3 because it is third moment. If you were to draw inferences from your data, first moment would be extremely simple and straightforward in terms of drawing the inferences from your data. Second moment, drawing inferences would be slightly difficult. And when you come to third moment, the difficulty level of you drawing the insights from the data would further increase in third moment. Then comes fourth moment, which is extremely difficult, meaning you need to spend a lot of time to understand the underlying data, the measures. That is, when you calculate skewness, you look at the skewness value, you look at the data, you try to understand the business problem in that, and then you try to solve it. So when you draw a histogram, you kind of understand the shape of the distribution. And let me also give you the shape of GMAT score. If you look at this, we have histogram of work experience and we have histogram of GMAT. Histogram on x-axis will have the random variable. Here we have work experience, and on y-axis you have frequency. Now, if you look at the histogram of work experience, and if you were to just draw a curve like that, you would see that there is a tail. Okay, there is a long tail towards the right side of mean. And when it comes to histogram, the mean will be at the center. At the peak, you'll see mean. At the peak, you'll find mean. And if you look at this, the data is appearing like that. This is skew. I mean, you see a tail towards the left side here, to the left of the mean. Here you see to the left of the, to the right of the mean. So what? This is a very important question that you need to ask. For every value that we calculate, you need to ask, so what? So let me give you an example of Netflix, because a lot of you all are familiar with Netflix, and that's one of my favorite examples. The founder of Netflix, before starting a company called Netflix, has taken certain movie DVDs on rental from a company called as Blockbuster. Okay, there was a company, not there was a company called Blockbuster, which was extremely famous. It was doing an exceptional job. And they used to provide DVDs on rental movies. And this guy once took a bunch of DVDs on rental, and he actually forgot returning the DVDs on time. Because of some, work, he wasn't available. And then when he has gone to Blockbuster to return the DVDs, Blockbuster charged him the late fee. He tried to request them and convince them that it was not purposefully done. But then Blockbuster never listened to him. And this guy was so upset on that day that he formed a company, and today that is called as Netflix. He's the founder of Netflix. And after he formed Netflix, he founded Netflix, he came up with a lot of user-friendly policies. You take the DVD, you keep it with you for unlimited time, doesn't matter. But if you want to watch another movie, return that and take this. And that was a subscription model. So you pay me probably $10. You watch unlimited movies in a month. So why would you restrict yourself to only one DVD? And why would you watch only a single movie? You might want to watch a lot of movies. So you return the DVD on time number one. So you're not charging any late fee from the customer because you're rest assured that you would reach, you receive DVD on time. So anyways, so let's get back to our histogram and try to understand more here. When Netflix wanted to venture into the business of DVD on demand in 1998, meaning if you want to watch a movie, you can take the DVD, watch it, and send it back. Then they found that majority of the market was here. A lot of market was here. A lot of people, when they analyzed this segment, they figured out that a lot of people falling in this segment wanted to watch super hit movies, blockbuster movies, or the latest of the movies, recent releases. That is what people were interested in watching. And the moment they figured out that here is where we have huge amount of demand, any company would venture into that segment. And Netflix also figured out that if there is huge demand in that segment, not just we, everyone else would want to be in that market because they want a pie out of that. And if a lot of other competitors are thinking on the same lines, then competition eventually will become fierce. And if the competition becomes fierce, people will go ahead with price war. So how do you generate value for customers? If you were to generate value for a customer, it is benefits. If you keep giving more and more benefits to the customers, the value, the way they value your product or a service increases. And when it comes to prices, it's inversely proportional. If you charge less, they will value more. So divided by price. Which one is more easy? Reducing the price, because if you reduce the denominator, the overall value will increase. Or if you increase the numerator, still the value will increase. If you remain if you let the price remain constant, same, and if you keep on adding more and more benefits, value will increase. Or if you let the benefits remain the same, and if you keep decreasing the price, value will still increase. So what would any competitor do? Which one is easier, adding more and more benefits or decreasing the price? Decreasing the price. Decreasing the price would be a lot easier for the competitors competing in a space, in a segment, in a business. If you drop the price, I would drop the price. You further drop, I would further drop. Eventually, there will be price war and the profits will shrink and the entire industry would go for a toss. Hence, what Netflix thought is, why get into these many complications? Let's do one thing. Let us look into another segment where we find a long tail. This is called as long tail. And when they analyzed this long tail segment, they found that this segment was a small segment. However, it was a niche segment. Though it was a small segment, it was a very niche segment. So what? So people here like to watch documentary movies. They like to watch black and white movies. They like to watch movies dated back to 1900th century, etc. Mythological movies, etc. Very small segment of people like to watch those kind of movies, but no one was supplying those kind of movies to this segment. So they thought, since the competition is actually non-existent, Let us venture into this segment and start catering to these customers. And since we are the only people who are catering to their service, we can charge some additional money and they would be willing to pay because you are the only one who is supplying that specific service. And when you start charging more, what will happen to your profits? Profits will increase. While all the other competitors are busy, in the price war, reducing the price, you're the player who is making consistent profit. Once you have sufficient profit, sufficient bank balance, sufficient corpus, you then go and enter into this segment and try to capture this segment. And eventually, entire market will belong to you. A simple histogram, a simple visualization is giving you so many insights to be acted upon. Such a simple histogram can actually make or break your organization. It can help you devise, right, earth-shattering strategies, mind-boggling strategies. So you should be very keen to spend more time in analyzing your data, calculating the various measures, and finally, you need to ask yourself, so what? And here we have the data. So we have negatively skewed data, normal data, and we have positively skewed data set. Negatively skewed means when you look at the peak here, when you look at the peak, from the peak, you will have a skewness towards the left side, or since it's to the left of the mean, it's also called as negatively skewed, or this is also called as left skewed. Then you have normal data, wherein mean, median, mode remain the same, and you don't have any skewness here. And then you have positively skewed data, wherein at the center, you have your central tendency value, and you have the skewness towards the right side of your central value, central tendency, and this is called as right skewed data set. The moment you see some tails out there, you know for a fact that there would be something interesting to be analyzed and figured out. Negative, normal, and positive. So when it comes to negatively skewed data, on this x-axis, what will you have? Say you have GMAT score or work experience, whatever. The GMAT score 600, 620, 640, 660, so on and so forth. So first comes mean, 640 or so, then say 660, 680, and here you get the median, and then probably 720, etc. Here you get the mode, right? So mode value will be the highest value, followed by median, followed by mean. And when it comes to positively skewed data, you'll have mean. Mean value would be greater than median value, and median value will be greater than mode. This is how the data would be. So you have negatively skewed, positively skewed, and normal data. This is how you draw insights from third moment business decision. Next. We have something called as fourth moment business decision, which is also called as kurtosis. Yeah, even before that, one more quick thing. When you look at the skewness value, If you get skewness value equal to 0, then we say that data are normally distributed. If you have skewness value less than 0, then you say that data are negatively skewed. If you have skewness value greater than 0, then we know for a fact that the underlying data is positively skewed. Okay, very simple. Skewness value equal to 0 means data are normally distributed. And whenever you see long tail, you know for a fact that there is some hidden insight in that. You need to go and dig into that, draw the insight from that, and take actions accordingly. There's no good or bad here. There will be nothing called as good or bad. Whatever your underlying data is, you get to see the visualization accordingly. Until unless you analyze, you don't know what's happening over there and what action you need to take upon that. Your actions that you take would actually help you become smarter, become successful. If you take wrong actions, devise wrong strategies on your data, then it would be a bad decision. Okay. And then we have kurtosis. Kurtosis, okay, let me wait for this to complete. Okay, so we have fourth moment business decision. And even before we talk about kurtosis, I think it makes sense for us to run the code in Python pertaining to skewness, pertaining to bar plot, and pertaining to histogram. Post that, we will get into kurtosis, talk about kurtosis, and then we will run the code pertaining to this as well. So let me get to the Python programming part of it. After your second moment business decision, we spoke about visualizations, right? So I would rather like to run these lines of code first. Okay, the data visualization part until histogram, and then we will calculate skewness. Okay. So we already discussed that there is a specific library matplotlib which will help you generate plots, do some data visualization. So you have import matplotlib.pyplot as PLT. So you run this. Then you have something else which is import numpy as NP. NumPy has numerical calculations within that. Matplotlib has data visualizations within that. Why can't I just import this? Why do I need to use as PLT? Because it is a short form. If you want to draw a bar plot, for example, you should have written the complete name, matplotlib.pyplot.bar. That would be lengthy. Hence, we are importing this using an abbreviation called PLT. And when we say PLT.bar, the bar plot within this visualization would be taken into consideration. And when you say education.shape, education is an object here, or a variable or a data frame. .shape would give you number of rows and number of columns that you have in this data set. So what are you doing here? You're saying, let me tell that in the bar plot, each bar, that is the height of each bar, should be the GMAT score. So when you go to this education, within that, you have this column called as GMAT. In order to refer to that, you have to say, go to education and pick this GMAT. Okay, and on x-axis, what do you want to have? On x-axis, you want to have a range of values in between 1 to 774 in an increment of 1. Start, end, increment of 1. What does that mean? You want to start with 1, and you want to end it at 774, but then within Python, the last number is ignored. And you want to do it in increments of 1. So 1, increment it with 1, you get 2. 2, increment it with 1, you get 3. 3, increment it with 1, you get 4, so on and so forth. Okay, so you're getting a bar plot. Let me run this. And here we go. So we have a bar plot here. Indexing starts from 0 anyways. So you have bar plot 1, 2, 3, so on and so forth. Okay. And the height of each of these bars would be the GMAT score. So you have that data. Obviously, we know for a fact that, all the students have GMAT scores greater than 600. Apart from that, it's very difficult to glean any meaningful information by looking at this. Hence, we discussed about a frequency plot, which is also called as histogram. If you say plt.hist and you're saying .hist means it will help you, generate histogram from matplotlib, which is this plt. Education.gmat, when you do that, there we go. We know for a fact that GMAT score is slightly skewed, and that is what we are seeing here. And we know that majority of the students have a GMAT score in this range, probably 710 to 725, maybe. Majority of the students fall in that range. Okay. Now, you need to ask yourself a question on how are the bins generated? How are the ranges of the bins generated? Each bin will have a range. Okay, like 600 to 620, 620 to 640. How is that calculated? And what is the default calculation? Right? This is something that we are going to talk about in the next module as well. We'll just complete the remaining lines of code. If you feel that I do not want to stick with the default bin sizes which are provided, and if you feel that you want your own bin sizes to be generated, sure you can. Okay, here you can just say that, what I want to generate bins from probably 600 to, let me say 640, then 680, then probably 720, then probably 760, so on and so forth. Okay, maybe 800, right? When you when you give the bins, it's going to generate these bins only. And you're also saying that I want an edge color. For example, if I were to just draw this, you have all the bars which kind of overlap one another. You don't have such a segregation. So you're saying that I want an edge color which should be in black color. So if you were to run it, there we go. It's giving you nice bins. The way you define 600 to 640, you have one bin. 640 to 680, you have another bin, so on and so forth. And since you're saying edge color should be black, do you see that black line segregating each bar from one another? Yes. And all of these, like bins and edge color, etc., which we are mentioning within this function, this call as a function. Within this function, you're calling these are called as attributes or arguments or parameters, different names. Okay. If you say that, what, I want a histogram, this time I want to generate histogram Okay, and I want to draw a histogram for work experience. And I want the bars to be in red color. And I want the edge colors to be black. And I want 6 bins to be generated. If you say that, bin 1, 2, 3, 4, and you have 6 bins for that case. This is 1 bin, second bin, third, fourth, fifth, and sixth. And you have everything in red color and you have the edge in black color. And when you say help, this plt.hist, you get a lot of help. You understand what are the various functions available. Do you see color? So that is what we are given here, color. Then I'll also do one thing which will be even better. I do not like this interface. So I'll go to view, Windows layouts, and then let me go to R Studio layout. Somehow I like this layout because it'll be easier for me to show a lot of things. You know, you have bins basically, which is one of the arguments here. Okay, so let me show you that these are the various things which exist, which are all called as parameters or arguments, right? Within histogram, these are the various arguments that you can use, what each of the argument means, what is the default value of that, everything is made available. Okay, choice is yours. You can play around with that. Okay, all right. Now, before we get into the box plot, I wish to, of course, we will discuss about box plot after we understand the theory. So since we discussed histogram, we generated the plots to see the various plots, and now skewness. Education.work experience.skewness. How would it be? For that, let me go to work experience. This time what I'll do is I would just draw a histogram on work experience without using any parameters. What's happening to a histogram? It is skewed. It is skewed towards the right side of the central tendency. So when you calculate the skewness value for work experience, obviously you would get a value which is greater than 0. So let me calculate skewness here. Education.work experience.skewness. It is 2.6. Okay, and you have the representation like that. Okay, like this. Okay, this is how the representation looks like. We'll erase this and I'll close this. Now, when we do the histogram for GMAT, look at how it's appearing. It is not as skewed as work experience, but yes, still it looks skewed. Okay. And since the skewness is towards the left side of the central tendency, you'll get a negative value, negative skewness. So let me calculate the skewness value for GMAT. So you're going to education. Within that, you're referring to the column called GMAT, and then you're calculating skewness, which is minus 0.59. Yes. So this is minus 0.59. And for this, you're getting 2.6. And if you have a distribution which is normal, which is neither skewed towards the left side nor skewed towards the right side, then you get a skewness value 0. And if the skewness is towards the left side, you get negative value. If the skewness is towards the positive side, you get a positive skewness value. The far away this value is from 0, more is the skewness. Since our GMAT score, when we have done histogram, the skewness was there, but it wasn't very prominent. Hence, you get a value which is closer to 0. But when it comes to work experience, the skewness was very prominent, and hence you're getting a value which is far away from 0. This is how you come up with skewness calculations, and histogram is helping you understand the shape of the data distribution, whether the data are skewed or are the data normally distributed. Right? This is what we are trying to, or this is what we have actually understood. So we will stop here, and in the next module, we are going to talk about kurtoses. We will practically look at kurtoses. Then we will understand box plot. We'll look into the practical aspects of box plot. Then we would get into QQ plot. Practically, we'll do that. Scatter plot. Practically, we'll do that. Finally, correlation coefficient value. Practically, we will solve that. And then we will get into the data cleansing activities.